All right, Unit 7, probability, which is really continuation of what we did in the previous chapter. So, a lot of vocabulary in this first page. Simple probability, lesson 1. So, probability is the chance or likelihood that something will happen. You know, if you think about it, oh, this will probably happen, okay? So, you have an experiment, not like a science experiment, you know, maybe for a science fair, but an experiment is an activity or occurrence with an observable result. Now, you observe results in a science experiment, but this is more like when you're flipping a coin, rolling a die, picking a card from a deck, all right? So, think about it. When you flip a coin, you could get, you know, heads or tails. If you roll a die, you're going to have a 1, a 2, a 3, a 4, a 5, or a 6. And picking 5 cards from a deck, I'm not going to write them all down, but you've got 52 cards and a combination, like we did in the previous chapter, of those 5 cards. Could happen. Okay? And so, the outcome, more specifically, is the results of that trial. So if you flip a coin 3 times, you could have 2 heads and a tail, 2 tails and a head, something like that. If you roll a die 2 times, you can get a 6 and a 4, 1 and a 3, 1 and a 5, something like that. Picking 4 cards from a deck, you could get King of Hearts, Ace of Diamonds, 7 of Clubs, 9 of Spades, any other crazy combination of those 52 cards. Those are outcomes. Now, the sample space is all the possible outcomes of an experiment. So for flipping a coin 3 times, you can have heads, 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 tails, all the way down to tails, tails, tails. There's 8 possibilities. I'm not going to read them all. Okay? If you roll a die 2 times, okay, and I'm not going to put the whole thing here, but you know, you could have a 1 and a 1, a 1 and a 2, a 1 and a 3, 1, 4, a 1 and a 5, 1 and a 6. Or you could have 2 and a 1, 2 and so forth, 3 and a 1, 4 and a 1, 5 and a 1, 6 and a 1, all the way down to 6 and a 6. And you would fill in that whole chart. Okay. Now, a 1 and a 2 and a 2 and a 1 looks like it's the same thing, but let's say we made these red and green die. A red 1 and a green 2 is different than a red 2 and a green 1. So those are different outcomes. Even though they're the same numbers, they're different outcomes. All right? So if you fill out this whole chart, you would have 36 different possibilities. Okay? Picking 5 cards from the deck, alluded to this earlier. You would have 52 combination 5. Not going to list any of those, obviously. It's too many. How many is it? Well, it's 2,598,960. That'd be a big chart. Okay? But that's how many outcomes there are. We didn't use that term in the previous chapter. Now, an event is a desired or requested outcome of an experiment. Okay? If the experiment's having a baby, the event might be having a boy. Okay? Now, to calculate the probability of an event, you take the number of possible outcomes divided by the total number of outcomes. Okay? So in this case, a boy is 1 outcome out of 2 possible outcomes. All right. And of course, that's in a traditional, you know, binary gender thing, which we talked about before. That is just kind of, becoming outdated. But when, these courses are written, they're written before we're getting to new knowledge. So in an outdated way, 1 out of 2 possible genders. All right, number 14. What is the probability of picking a king from a deck of cards? Well, there are 4 kings in the deck, and there are 52 cards in the deck. Or there's 1 king in each suit of 13 cards, and that is the reduced way of that, and we always want to try to reduce our fractions, okay? And the calculator will do this for you with the math fraction key. So, for example, if you did 4 divided by 52, you get a decimal. But if you go to the math key, see where it says fraction, it's already highlighted, just hit enter, enter, there it is, 1/13. So it gives you the reduced fraction. All right, moving on. What is the probability of picking a queen or, all caps, an ace? Well, when you remember, or means add. Okay, so that'd be 4 out of 52 plus 4 out of 52, which would be 8 out of 52, which would reduce to 2/13. What's the probability of rolling an even number on a single die? Well, there's 3 possible outcomes out of 6 numbers. So 1 out of 2, 50-50 chance. What about getting an 8 on a single die? Well, it ends at 6, unless you're playing D&D. So that's 0 out of 6, which is 0. A number less than 8. Now, can you get a 7? No. But every number on a die is going to be less than 8, so that's 6 out of 6, which is 1. Absolute. You're sure of it. You will get a number less than 8. Now, the probability is actually between those two numbers. Greater than or equal to 0, less than or equal to 1. So, 19. 2 seniors, 4 juniors, and 8 sophomores. Okay, that's a total of 14. Submit editorials for the newspaper. If one is chosen randomly, what's the probability it's a senior? Okay, well, there are 2 seniors out of 14, so that's a 1 in 7 chance. Now, here's a new thing that's going to combine what we learned, no pun intended, knowledge from the previous chapter. Same situation. Now we're choosing 3 randomly. What's the probability they are all sophomores? Okay, so remember, the probability is the event over the total. So the event is what we did in the previous chapter. So we're going to do 8C3, whatever that number is. That's how many possible ways 3 can be chosen from the 8 sophomores. Okay? But the total is, there's 14 total, combination 3. Okay? So this right here is 3 being chosen out of all 14, and this is if they were all sophomores. Okay? So you run those 2 numbers. So this top number is 56, and the bottom number is 364, which reduces to 14/91. Now let's just go a step further off the page. What if it was all juniors? Right? Well, in that case, we're talking about 3 people being picked from 4 juniors. And again, the bottom number is not changing because that's the total. So this number would only be 4 out of 364, which is 1 out of 91. And just for the heck of it, all seniors. Now remember, we're choosing 3, but there's only 2. So that's not possible. You cannot pick all 3 from the senior class. And that's it.